been so many days passed by I didn't streaming. Okay, I'm going back. Equilibrium is the topic. Equilibrium, dissociation of molecules. Okay, something because it's connection. There's a connection with the previous talk about dissociation. Okay, like that. Okay, so when we talk about dissociation, as we can remember, there's a difference between dissociation and ionization, right? Because when we speak, oh my gosh, microphone is clearer now. Because when you speak of dissociation, there's an ionic band between the molecules, okay, that hold together in a compound, especially reaction to the metals or elements like that. Okay, so it will become inorganic compound, or it could be anorganic particles or negatively charged ions and the positively charged particles or the positively charged ions. So the positively charged particles or ions is called, okay, what? Called cations. Okay, the negatively charged ions or particles are called anions. Okay, something like that. So there's charges that reacting with each other, okay, so that both of them will become neutral, something like that. So the charges will become to zero, like that. So it will become to zero, so it will be in equilibrium, okay, with each other. So when you reach the equilibrium stage, at that time, it will become a compound clipping with each other. Could it be the, not could it be, but it is specifically, or the positively charged particles and negatively charged particles, okay? Like that. Ionic band, okay? So we understood about ionic band is that gonna be like that. So for example for the salts, okay? Salts are mostly electrolytes because there are ionic bands between them, okay? So the question will state like this, it is a bond or a chemical bond that involves negatively charged particles plus the positively charged particles. Okay? So, for example, in a certain examination, if it is fill in the blanks examination, okay, in examination, there's a lot of types of examination, right? We have the multiple choice, okay, we have the fill in the blanks, enumeration, outline, list, describe, define, okay, explain, discuss, or it could be an essay form of examination. Okay, but nowadays, okay, in the millennial stage, most of the exams are multiple choices. Okay, like that. Okay, direct. There are the screen. I was interrupted. Sorry, I was interrupted for a while. My screen for a matter of seconds. Don't worry. So, the question goes like this. This is a fill in the blank type of examination. Blank twice. Okay, blank is a chemical bond that involves and positively charged particles. So for example, if I have to create choices, A, non-polar covalent bond, B, polar covalent bond, C, polymerization bond, D, ionic bond. Okay, your answer will be automatically ionic bond. From the word ion, the root word of ion is ion. And positively charged particles and negatively charged particles are all ions. The clue is very clear. Ionic bond. Okay, applied usually in electrolytes, mostly salts. Okay, salts. Sodium chloride, sodium bicarbonate, something like that. A lot. Sodium carbonate, magnesium carbonate, something like that. Salts. Okay. So, if we speak about salt, that is the result of neutralization reaction. Okay? So, it's very clear. Neutralization reaction. So, it becomes neutral because the charges are different. Positive and negative. Okay? And we produce a salts. okay, in a neutralization reaction, something like that. So weak acid plus weak base will produce salt plus water. So it could also be strong acid plus strong base will produce salt plus water. But since we add strong acid and strong base, automatically our salts are also strong. Common sense. And if we add weak acid and weak base, common sense, our salts are also weak. But the water are always stable in nature. Okay? Something like that. Okay? So neutralization reaction, example of an ionic bond, because it involves negatively charged particle plus the positively charged particle. And our best examples for that are hydrochloric acid. Okay? Okay, hydrochloric acid plus what? Hydrochloric acid plus sodium sulfate, like that. Okay, sulfuric acid plus salt, that's for example sodium hydroxide. Okay, or it could be sodium hydroxide plus hydrochloric acid, something like that. Okay, so if we add strong base, for example, strong base is sodium hydroxide, okay, plus strong acid, which is HCl, it will produce a strong salt, okay, like that. It will produce sodium chloride, okay, like that. We don't have to show, because I don't have the paper right now, later I will be showing to you that, because sodium chloride is a table salt plus the water, okay. So it's gonna be, I don't think so if it is a reversible reaction, if you try this one too. Yes, it could be. Anybody, any BS chemistry students watching me right now, or any chemical engineering students watching me right now, or any sciences courses, especially if you are not in the topics of chemistry. Okay, so it's gonna be a reversible or irreversible reaction. Because if you add also water to sodium chloride, it will create also, it will produce also the, the sodium hydroxide plus HCl. Okay, like that. So some questions are gonna be tricky questions also, especially in the theory. Okay, because most of the theories, okay, it should only be 40% problem solving. Most basic theories you will fail in the examination. Okay, so you should go back to basic, to the most basic concepts or theories, because in the difficult problems you can still answer some of it. Okay, if you can still answer some of it plus the basic theories and concepts, let's say you have 50 plus, then 20 plus, something like that in the difficult, then you passed. Okay, plenty of most I could say engineering graduate or whatever, it's very difficult. Okay, in BS chemical engineering, you have to focus more on the theory, concepts, principles, laws, something like that. Personally, me, as a licensed and registered chemical engineer, I focus more on the problem solving. Okay? Difficulty to focus on the problem solving directly. I must understand the concept first, the theories first, before solving difficult problems, so that I can understand what the formula came from, and then when we derive that one. For example, if we connect the theory of relativity, Albert Einstein, the energy theory to the, for example, to the kinetic energy formula, okay, by derivation, something like that. Okay, so, but it really helps you a lot to practice in the problem solving. Okay, but never forget the theories. Because sometimes the questions will be like this. For example, blank is a reaction of salt and water to produce acid and base. Okay, so your answer choices: A, humidification; B, evaporation; C, crystallization; D, gas absorption; E, distillation; F, blah blah blah, so and so, screening; okay, flotation, operations. But the answer is mainly a simple one, which is the hydrolysis, something like that. See, a lot of shun in the BS chemistry or in a chemical engineering course. So all you have to do is to understand and memorize all those shon, ends with Tion. Okay? Evaporation, sublimation, solidification, something like that. Okay? Isomerization, polymerization, okay, neutralization, something like that, blah, blah, blah. Crystallization, evaporation, blah. All shun, memorize it all if you want to pass this chemical engineering board examination, something like that, okay? Because when I was in college, I memorized, not all, most of it I memorized. Most more the problem solving really, okay? Like that. So that's gonna be the balancing of your preparation in it. Not only for the board examination, for other examinations also. Because most of the industries right now are involving science examination also, right? Measuring the IQ of the uh, application of the, of the what you call it? Applicants. Applicants. My God, may ganun ba? Okay. Sobra. Bakit pupunta ako doon? Okay. Let's go back to equilibrium dissociation of molecules. Okay. In this particular topic, the most important is we know what is really the degree of dissociation. Okay, when we talk about degree of dissociation, there's something, what's in our mind, there's a splitting of molecules, there's a decomposition of molecules, and then there's a separation of molecules from the original compound. Compound, but it could be an organic compound, it could be a salt or electrolyte, something like that, okay? And then we will add that with sometimes with water, okay, something like that, in a solution, okay? So in acidic solution, in a basic solution, something like that, and you can create your own product. So that technique in equilibrium dissociation, okay, of molecules, first thing to do is you are very expert and adept in predicting the products. You will also study the products of those chemical reactions, especially the basic chemical reactions, so that you will not be lost. That's why I discussed you last 3 weeks, last 4 weeks, something like that. I discussed you already the 5 types of chemical reaction, if you can remember that one. Okay, the synthesis, the combination, the decomposition, the combustion, the single replacement, the single displacement, the double displacement. So that would be a very great help in the equilibrium dissociation of molecules. So you should remember that one. Okay? So we apply that one. And after that, getting the complete products out of the reactants, we need to balance the chemical equation. Okay? That in our balancing of the chemical equation, we are really recalling or understanding the conservation of mass or law of conservation of energy again. Chemistry is always just like this. Okay, so law of conservation of mass, law of conservation of energy. Again, by basic theory, as far as I can remember, last 20 years ago. Okay, law of conservation of mass. It states that mass can neither be created nor can be destroyed by ordinary chemical means, something like that, or it could be applied also in energy. Okay, that's why Le Chatelier's principle will be applied there. There's a shifting of certain reaction. If you add energy to the reactant, where does the reaction go? It will be in the left, it will be in the right if we apply pressure on the reactant. If I will apply pressure in the product, what will be the direction of the reaction? It could be in the reactant, it could be in the product, something like that. So that's Le Chatelier's principle. So if you are studying chemistry, you will never forget Le Chatelier's principle that is discovered in 1810, as far as I can remember when I took up my chemical engineering college. That is Le Chatelier's principle in 1810. Okay, so it states that whenever a stress is applied to a system of equilibrium, the equilibrium will shift in such a way to reduce the stress. What does it mean? Okay, so the stress there, it could be either various variables. It could be the temperature, it could be the pressure, it could be the concentration, or it could be the nature of the solute or the nature of the solvent. Remember, these are very important factors that affect our dissociation of molecules. Remember, this is the opposite of the colligative properties. Because in the colligative properties, it depends only the nature of the solute, the given solvent within the solution. Okay, but in this equilibrium factors that affect the dissociation, the degree of the dissociation. So what are those? Okay, the nature of solute, the nature of solvent, the concentration, temperature, okay, temperature, the concentration of the solution, okay, like that. Four or five, plus others, but others are not really the relevant. This is only the relevant. Okay, it could also be pressure, like the temperature, volume. Okay, other variables also could affect, especially if we have exothermic reaction, something like that, applying heat to a certain chemical reaction. Okay, so if you apply heat, so there's a tendency it will break up the molecules into certain products. Another thing also, another byproduct, something like that. Like that. And there will be an incomplete product first, and after it will produce another final product, and then blah blah blah, so and so, another byproduct. So it would be coming from the unstable one, something like that. Okay, so you should remember that one also. Okay, very clear. We can now differentiate. So, if I will be your instructor, let's say, if I will be your professor in a certain university or college institution, I will ask you, okay, class, my gosh, may ganun. Okay, sorry for that. Okay, okay, I will ask you a question. Okay, class, differentiate between colligative properties and the degree of the dissociation of molecules. My tongue will be twirled. I cannot pronounce it properly. Equilibrium, dissociation of molecules, or the degree of dissociation. So will be answer. You have to only to state the definition or the explanations regarding the qualitative properties versus the definitions and the discussion pertaining to the degree of dissociation, something like that. It could be a question usually in the last part of examinations, especially in the final exam. We have prelim exam, midterm exam, and the final exam. Okay, something like that. And then it would have always theories. It's impossible there will be no theories. Yeah. But the problem is in college you will be focused more on the problem solving because you are an engineering student. Okay, other fail to focus more on the basic concepts and theories. That's why when the examination will be coming, the questions will be a little bit not difficult. Sometimes others, not all, they will be misled and confused already because they are focusing on the more difficult one. Okay, something like that. Sorry. Equilibrium, dissociation of molecules. My gosh. Okay. Thank you so much for watching me right now for my YouTube live streaming. Okay. I'm alive now. Okay. I'm rested for a couple of, I think, 3 days or 4 days. I don't know. I did not count the days where I did not do my live streamings. Okay, but I am very now dynamic and very agile to discuss once again topics of chemistry. So I told you that the topics of chemistry are interrelated with each other. Okay, like that. So this is very more interesting because this is a core foundation of pure sciences. Okay, there's a lot of pure sciences as you can remember, right? Biology, geology, physics, something like that. Okay, and then this chemistry is the core, meaning the foundation of all. Okay, with a lot of chemistry, you have the nuclear chemistry, environmental chemistry, okay, clinical chemistry, okay, biochemistry, a combination of biology and chemistry. We have quantitative chemistry, we have qualitative chemistry, we have physical chemistry, we have inorganic chemistry, we have organic chemistry. A lot of chemistry is all around us. So it's within the planet Earth, within the atmosphere. stratosphere, may ganon, hemisphere, blah blah blah, so and so, okay, like that, and it's very enjoyable because without chemistry we will not survive, okay, we will die all without chemistry, okay, that's why we need to know the basic core foundation of science, which is chemistry or something like that, okay. So going back to the chemical equilibrization dissociation of gases. So equilibrium, again, we need to, to discuss the term equilibrium. So equilibrium meaning to say we are abiding or following the concept of law of conservation of mass and law of conservation of energy. By the way, guys, I asked you long time ago, right? Who is the father of modern chemistry? I remember now. It is Antoine Lavoisier. Okay, he is the father of modern chemistry. Okay, as I recalled, I did not research back, but it's coming back into my brain that it's Antoine Lavoisier is the father of modern chemistry. Okay, because last weeks I forgot, and now I remember. My gosh. Biruin nyo, 40 years ago na yun. Okay? So, at least it accumulated once in a while. Okay? Because we are in the aging process, our retention is not that very quick compared in our younger years, right? Let's accept it. Okay? Something like that. Okay? Oh my gosh. So going back to the equilibrium dissociation of molecules. So, we need to determine first the degree of dissociation. I have to write in a piece of paper, right? So the degree of dissociation represented alpha. So, andito na naman tayo. Sir, bakit alpha? Because most of our scientists before are Greeks, okay? Living in Greece. That's why the alpha, beta, gamma are language of Greece or Greek scientists. Alpha, beta, gamma, blah, 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 so and so. So these are the symbols usually used by our previous scientists. Okay, something like that. Okay, in radioactivity and in radiation. Okay, like the X-ray. X-ray is an example of radioactivity and radiation is the process, right? Like that. Okay? Blah, 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 si Henry Becquerel, o, di ba? Ano naman si Pierre Marie Curie, okay? Discovered, blah, 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 radioactivity. O, ano na naman tayo? X-ray, discovered by Engr, okay? In your high school, right? If you stock that in your knowledge, you can still remember, okay? Like that, about radiation, about radioactivity, blah, blah, blah. So alpha, beta, and gamma ray. Okay, something like that. Okay, so later we will be discussing to that is under nuclear chemistry also. Part 1 types of chemistry. Nuclear chemistry. Usually it deals with atoms, protons, neutrons, electrons, something like that. Positrons and photons, you will understand that there. And then the decay of different elements and metals also. The half-life of certain elements are being discussed there. Also, how to compute the mass of the element, okay, the mass number, the atomic number, the AMU, the atomic mass unit, and everything, chuba chuchu. It's there in the periodic element. That's under nuclear chemistry. And in fact, studying the periodic table, their behavior and characteristics are under nuclear chemistry. Okay, something like that. We have also metallurgical chemistry, talking about elements, metals, underground, okay, in the Earth's crust, something like that. Naturally occurring radioactive matter. Okay, you can study it in 1 year. Okay, you can study it for 1,000 years, something like that. But the basic will still be coming. Okay, because there's no new scientists that have their own formulas. We're going back to the previous scientists that we use now in our textbooks, like that. still the same theories and principles and equations that we'll be using, okay? Like that. But every day is a new discovery in science. Only that we have to prove it before using it in our daily lives. Something like that. Okay? Especially the artificially prepared elements. Okay, those are discovered by new scientists. Okay, not the long time ago scientists, the new scientists. That's why we have that in our periodic table. Artificially prepared elements are discovered by various scientists. Blah blah blah. Chuba chu chu. Okay, like that. Okay, going back to equilibrium dissociation of molecules. Nandiyan na naman tayo. Oh my gosh. So, wala ba akong papel in fairness? Wala akong whiteboard or green board to discuss properly, systematically, all, not all, some topics of chemistry. Okay, something like that. Okay, so forgive me because I don't have lessons. Don't have lesson plan. Okay, I cannot do this in a in a what do you call this one, in a timely manner or in a very organized fashion, something like that. Okay, I'm just choosing topics interconnecting with my previous topics that I discussed last 2 weeks, last month, something like that. Okay. Okay, going back. So I have my two notebooks here. As you can see, I bought these notebooks. Okay. This is my notebook for the mathematics. Okay, for the basic mathematics. Okay. And this is, oh my gosh, this is my notebook in science, pure sciences that I discussed a while ago. Okay, something like that. Okay. Then I have also here references of my various examinations. Charot. Hala ka diha, June. So these are my OSH examinations references materials. Okay. OSH, occupational safety and health. Okay. Because you should prepare a lot before joining the employer interviews or whatever, or any examinations you wanted to pursue, like that. Okay. And now I am very, very happy that Rodec Training Center, one of the reputable safety training centers in the Philippines, picked me up as one of their online OSH trainers. Thank you so much, Sir Will Viado, for trusting my capability to handle safety trainings online also. Okay, so they choose me, but I will try my very, very best. Okay, like that. I'll just submitted my, my credentials to them and they approve it. Of course, because they selected me, right? Okay, and then I am one of their online trainers. Trainers. By the way, in English, I confused this so many times. It came from my mind. Oh my God. English, again, English, science, and mathematics, okay? I love these subjects, okay? English, okay, go back. Off topic muna tayo ha sa chemistry. Okay, I read a lot of words trainers and I have a lot of word trainers. What's the difference? Okay, so in English grammar, for example, if I am if the person sings, I am a singer. Okay, regardless professional or amateur singer. As long as you do singing, automatically you're a singer. It doesn't matter profession. Okay? If you dance, you're a dancer. So the rule in English, you have to add er after the root word, right? From a noun, something like that. Then, if I am a person who loves to train somebody, whatever, okay, could I be a trainer or a trainer? Remember, let's go back to the basic. We will only add er, right? So it should be trainer, not trainer. But why other statements I read in the web page, in the internet, something trainer? So where's that rule like that? It deviate the rule of grammar in adding er from the root word train. Train, T-R-A-I-N. Not the train running, ha? Running train. No, it's not. Train. Okay. To mentor, to teach, to educate. Something like trainer. Okay, let's say paint. I'll paint. So I am a painter. I am a painter also. So there's a confusion, right? Or it could be based on the UK English or English from America, something like that. I don't know. Because there's also rule for that. For example, color. UK used COLOUR, but America using only COLOR for color. Okay? For example, another thing is I cannot give another example. There's a lot of examples also for that. Okay. Okay. So trainer. Let's use trainer na lang siya. Okay, para safe. Not trainer. Okay? Like that. Himay-may lang siya. Term to term. Okay, so that we can understand properly. Okay, something like that. Okay. Going back. Oh my gosh. I'm talking too much, then my my screen also was interrupted. Okay. My gosh. Hello guys. Oh, thank you so much for watching. Kung sino ka man, shout out to you there. Okay. Like that. Our medium instruction in the discussion and explanation will be in English language because this is an international language all over the world. Okay, please forgive me that you can say that I am, overacting something like that or awkward. No, it's not. I really love to talk in English as my medium of instruction. Okay. Talk also Bisaya, of course, because I'm a Bisaya. I can also talk Tagalog because I am a Filipino. But I love to talk in English because I am comfortable well. Okay? Because I practice this since I was in high school, college, something like that, doing my reporting or whatever. Okay? So it's easy for me to talk in English. Okay? Like that. Please forgive me, huh? Okay. Like that. Okay, going back to the equilibrium dissociation of gases. Okay, not only gases, ha? It could be acidic solution, basic solution, blah, blah, blah. Paper na siya. Oh, reminder, there's no such perfect grammar here, ha? Because it's informal speaking only. Informal speech doesn't have to have perfect grammar. Okay, sometimes I use understood, understand something. Never mind for that. The important is that the essentials are the most important one, the substance of the discussion. Okay, because I'm not majoring in English. Okay, in the first place. Okay. For example, I get paper, something like that. Okay, so the paper was not yet taken, so that's supposedly get, not got, but I used got. Okay, don't be bothered with that. Okay, something like that. So I'll get paper now for some illustration. Okay, for you guys to understand properly what I'm talking to, I will need to get paper at this point in time. I have this much paper. Okay, I have to use this notebook also. Okay. Notebook face. Okay. I'm using of B. Of course, I practiced first my chemical engineering profession before going to the safety engineer profession or career. Okay, like that. So I've been to laboratory analysis also, like this. Before, and I climbed also some process lines, something like that, to analyze the gaseous components, blah blah blah. I'm already done to that. Okay. In fact, I already analyzed also some of the fluid analysis during my chemical engineering in Southern Power Corporation. In my what do you call this one? Before you graduate, I did the OJT, on the job training. Okay, so I used to be in the laboratory like this, analyzing the fuel content, and we have a distillation column, blah blah blah, so on and so. Okay, the world could be a chemical engineer, something like that, or a chemist, something like that, because we are more on the calculation side, okay, on the process side. We are more on the outside environment rather than the inside environment. Okay, that's the difference between the inside only in the laboratory. You need to go out to check the process lines, okay, the different chemical and physical separation processes of those manufacturing. Occupational safety enjoy them rather than if I am an engineering, I could not really do my inspection well, okay, something like that. Okay, because it's really you really understand the flow. Nandun na naman tayo sa mga momentum transfer, mass transfer. Meron kaming subjects na ganun ha, in fairness. A little bit similar to mechanical engineering. Okay? We have also thermodynamics, something like this. Okay? Fluid mechanics, and Okay, where's that my... Okay, my gosh, where's my pentel pen? See, because I don't prepare my streaming, okay? So you found it very, what do you call this one? Random. Okay, that's the best term, random. Okay. Okay. Hello guys. I forgot to take scratched paper from the office. Okay. Like this. Okay, degree of dissociation will be alpha, right? Okay, alpha, oh my gosh. Ganun siya. Alpha, or the degree of the dissociation, equals to the number of molecules dissociated. Number of molecules. So by the way, so as your starting point also in chemistry, you have to understand the difference between a molecule, charge, memorize the definition of those terms. You don't have the basic knowledge what is an ion, something like that, okay? 4, okay? An ion like that, okay? You have to understand the number of molecules dissociated, right? And this can contribute to, we need to have also, and eating also fruits and vegetables, something like that. Okay? Most of the energy drinks have electrolytes. It will keep us strong and very active all the time. We're energetic, perform, and it will become very strict with the wording. It should electron. No, it's not. Our previous scientists before. Okay, especially Antoine Lavoisier, the father of modern chemistry. Something like that. Okay. Charot. Green Pendleton, because I love green color, because it's a symbol of environmentalists. And this one,